So let's look at number 1. The base of our solid is going to be the region enclosed by x equals y squared, so this sideways parabola, and x equals 9. Things are a little bit of an angle to try and get a little 3-dimension going here, the look of 3-dimension going. So this whole region right here is the base of our solid. And the cross sections are perpendicular to the x-axis, so they're going to be going this way, like the base of them are going to be going that way. And our cross sections are going to be squares this time. So again, it's like slices of bread that make up the whole loaf. We're just looking at one slice. So I'm going to look at one slice over here. I'm going to draw a line that's parallel to the y-axis, perpendicular to the x. And from there, going up, we're going to have a square. So I'm going to draw 2 lines going up, the same size, and then connect them. So I know it doesn't look like a square, but it's kind of at an angle, 3-dimensional. And we want to give this slice just a little tiny thickness to it. Right? And that thickness is going to be our dx. Right? So this is basically just a prism, right? This little slice of the whole loaf is a prism. And volume of the prism, length times width times height. Yes. It's white bread. All right. So this right here, what's the area of a square? Side squared, right? Base times height, but the side's the same, so area is going to be side squared. Sorry. I was showing that all the sides are the same and the angles are the same. Area of a square. Alright. So, this is one side, this is one side. So the area is the side squared. Well, we need to write this formula in terms of x. So we need to figure out what's this side in terms of x. Well, to figure that out, we're going to take the top function minus the bottom function. Well, they're kind of the same, except that it's not a function when you have it all together. But if we look at the top part and the bottom part, we can look at 2 separate equations. And if we solve this for y equals positive or negative square root of x. So the top part of this graph is going to be positive square root of x. The bottom part is negative square root of x. Right? When you graph this in your calculator, you get 2 halves. You graph both of them to make this whole sideways parabola. Top part's going to be the positive one. Bottom part's the negative one. Well, then, to find this measurement, we have to take this top y value minus the bottom y value, but in terms of x. So we're going to take square root of x minus negative square root of x. So that's really like square root of x plus square root of x, or 2 square root of x. So that's the length of one side of the rectangle, or of the square. Remember, there's lots of different slices that go through here. They're all going to be different, but they're all going to have this formula. Each side is going to be 2 square root of x. So if we're at x equals 3, it's going to be 2 square root of 3. But if we're at x equals 5, it's going to be 2 square root of 5. So it's going to be a different size, but it's still going to keep that same shape. So now we need to write our equation in terms of x, our area in terms of x. So we know the side is 2 square root of x. We just have to replace that in this formula. So area in terms of x is 2 square root of x squared. So if we square that, we just end up with 4x for our area. So our definite integral is going to go from a to b. So what's our smallest x value? 0. Biggest x value? 9. And it's going to be the area, which is 4x, times that thickness, or height, which is dx. Now, we haven't done one of these by hand for a while, so let's do this one. It's pretty simple. Remember, do the antiderivative. We're adding 1 to the exponent, and then dividing by that new exponent, so we get 2x squared. And we're evaluating from 0 to 9. So So we get 2 times 9 squared minus 2 times 0 squared, or 162.